Hey guys, welcome back to Algos Explained. It's David Kim, and we are looking at another problem from Code Wars. This one's level 7, and this is part of the First Look series. If you're new to the channel, First Looks is when I haven't seen the problem before, and you get to see me attempt it for the first time. And so let's go ahead and try this one. This one is called Money, Money, Money. Mr. Scrooge has a sum of money, P, that wants to invest and he wants to know how many years why this sum has to be kept in the bank in order for this sum of money to amount to D. Okay, so he has P, that's the starting. He has to do Y, the amount of years, or Y amount of years is a variable that is unknown, apparently, and he wants to get to D. The sum is kept for Y years in the bank, where interest I is paid yearly, and the new sum is reinvested yearly after paying tax. Okay, cool. Note that the principal is not taxed, but only the year's accrued interest. Note that the principal is not taxed, but only the accrued. Okay, so I'm assuming that interest, you mean the interest gained is taxed. Yeah, that makes sense because you get taxed on gain, not just for having a principal amount of cash on you. Or anyways, let's look at this example. Let P be the principal. So you got like $1,000. Let I be the interest rate of 5%. Let T be the tax rate of 18%, and let D be the desired sum. So he just wants to make $100. How long is he gonna have to do this for? And it looks like after the first year, you'll get 1,041, and we might as well go ahead and try to follow along with that here. Let's see. So he has let's do let P equals 1,000, and we don't really need to double check this math, but just to make sure we have the best understanding of it as possible, that's why we're doing this on the side here as we follow along the example. All right, so let I equals 0.05, so that's like a 5% interest rate, and T equals 0.18, it's like an 18% tax rate, and D equals $1,100. Excuse me. So he just wants to make $100 off his 1,000 investment. Let's see. So after the first year, he's gonna make $41, which is P times the interest rate I. Okay, so that's $51 he's supposed to make, but he gets taxed on that. So P times I minus, what is it? P times I times T. So P times I times T. Cool. So what happened right there was P times I represents the interest gained if there was no such thing as tax. But because there's tax, we need to subtract tax from it. And so how much tax are you going to be paying? You're going to be paying this much, which is, we saw the P times I, that's the interest gained. And we just want 18% of it, so we just times that right there. And so we took the total interest gained minus the amount to be taxed, and so now we end up with 41. So 41 plus the principal would be 1041, which is that first year, and the second year is probably the same math, and the third year I think I have a pretty good understanding of what kind of math needs to be done here, so let's go ahead and continue reading this. Thus, Mr. Scrooge has to wait 3 years for the initial principal to amount to the desired sum. Your task is to complete the method provided and return the number of years as a whole number in order for Mr. Scrooge to get the desired sum. Assumptions. Assume that desired principal D is always greater than the initial principal. So good. Or else we'll just have to do 0 years. That would have been a very easy base case anyways. However, it is best to take into consideration that if the desired principal D is equal to P, this should return 0 errors. Okay, so we can assume that D is always greater than. So well, if we can assume that, I'm not going to make a case for that, even though they did suggest that it is best to take into consideration. So consideration taken, I'm not going to write it out because you guys said I don't have to. All right, and I am going to, let's keep those variable names just because they are well written. And so we are going to do one thing that's not on here is the ears that's going to take. And of course it's not here yet because it shouldn't be an input. So ears, and we're going to say 0 for now. And so we are going to now, we pretty much have to do this math over here. And while, let's say principal is less than desired. So pretty much we're going to have to do this math until principal is above desired. It can be equal to, so we have to put principal, wait, no, as long as it is less than. So the moment it becomes equal to, then the while loop will break. So, okay, this is good the way it is right now. And so at this point, we need to increment the principal by the amount it should be incremented by, which is pretty much this math here. And we'll call it gains equals principal times interest minus principal times interest times the tax times tax. And so we know that that is going to give us the gains, and we're going to do principal plus equal gains. And so this while loop will keep on running until, or pretty much what's going to happen is, say this first example over here, the principal, they're going to give us 1,000, interest 5%, tax 18%, desired is $100 on top of the principal. And so until principal is less than, or while the principal is less than the desired, this is going to keep on running. And what's going to be running is gains equals principal times interest. And so that is pretty much the total interest gain non-taxed. And so now, because we have to tax it, we need to subtract the tax amount, which is calculated with this right here, principal times interest times tax. And so now the gains is pretty much this 41 at the first iteration, and principal is plus equals gains, which is going to be 1041, like denoted right here. And pretty much it is going to continuously increment the principal so that now the interest can be on the principal. And I want to make sure that they are, I don't know if the right term is called compounding, but let's make sure it is. And so now 1041, okay, how about this? P plus equals 41. Okay, cool. And so now when we run this again, P is gonna have changed. And so now we're adding that, which is gonna be like 84 something, 83. Okay, cool. 83. It looks pretty similar. And so, yep, it is the same. And now we know that the interest is additionally added on the gains. So all we need to do here is ears plus plus to make sure every time this runs, we know that a year has passed, and we're going to return ear. We should call that ears because we're not sure how many ears it's going to take. We don't always know that it's going to take one ear. Okay, cool. So I feel pretty good about this. I'm going to go ahead and attempt it. Cool. So it passed all of them. Let's go ahead and submit it. If you enjoyed this video, be sure to like, comment, and subscribe. And check out the other playlists. I have more playlists of different levels of these first looks. And thank you for watching. This was Money, 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 level 7.